Hello and welcome to a new video. Today I want to show you how I built a Gameboy printer. So it all started when I hit up Dave and was like, hey, let's build a Gameboy printer. And he was like, all right, let's go. And we met at Hardware.io and started the project. But how do you even get here? So I knew there's a thing called the USB to Gameboy link cable adapter by Stack Smashing, and he used that to play Tetris online. And I had a few of these lying around, which I never really used. And when I met at Hardware.io, he was so kind to give me two more. So I had a couple to work with. And I decided that I wanted to connect a Gameboy to the one side and the USB thermal printer to the other side. There were previous projects related to the Gameboy printer, for example, the Pico Gameboy printer. And there you could connect a Raspberry Pi Pico to your Gameboy, and it would host a web server on the Pico, which you could connect from your phone or from your computer when you plug the Pico via USB to your computer, for example. And then the Gameboy would print to the Pico, and you can download the PNG on your computer from this web server. But I wanted to have an actual physical print. So if you think of following along, unfortunately, buying these is as much of a myth as iPhone kernel debugging. However, there are alternatives. Basically, you really just need a level shifter to shift 5V to 3.3, and that's really what there is to it. So Dave and I started working, and I started working on the USB side of the thing, trying to communicate with the printer, which used a somewhat custom protocol. And Dave looked at the Gameboy side of things, trying to figure out how to get an image from the Gameboy and then to convert it into something the printer would understand. So not too long after, I could figure out how to send commands to the printer so that I could print something. And then I could start trying to combine what Dave was working on, which was having an example image hard-coded in the firmware and trying to print that. The first couple attempts didn't go too well, and it didn't really help that he used a completely different printer than I did. So we kind of worked on different things because his format was different. And eventually I could manage to print the demo image that he saved in the firmware. So then I started trying to print images from my Gameboy directly, and as you may or may not be able to see, it doesn't look quite right yet. But after a couple attempts, I could get it working. So you can see a few issues with the image yet. For example, the Pokemon icon is very dark. This is something we fix later. Then the image is split in half, and there's this little weird thing at the top left on the upper and the lower image, which we will get rid of later as well. Eventually I could fix all the issues, and we had a working demo, which was pretty neat. So you can see the previous part was a little speed up. This is now the original transfer speed. Right now it takes quite a moment to transfer the picture from the Gameboy to the printer. And yeah, finally working. As you can see, just a couple attempts. And you can see the icon is not dark anymore. We have proper grayscaling. We removed the thing at the top left, and the images are now merged into one. So essentially the source code that we used from previous project wasn't doing things quite right. So after rewriting parts of, basically rewriting the full state machine, we got it working quite nicely. So after the demo setup was working, it was time to put everything into a production setup. I did a couple tests to figure out what I could do, what the limits would be, and it turned out I can power the Pico from the Gameboy itself. After a couple tests and a bit of debugging, which I didn't know, apparently the square on the board does not mark the ground pin, which I always assume, but seems like that's not the case. So after figuring this out, I could finally build a demo setup where the Pico would be powered from the Game Boy, and the printer had its own internal battery, and I could print without being attached to anything. So I had finally my working printer, but I didn't want to stop here. I wanted to put the Pico into the printer. That would be really cool. So I started by taking the printer apart, and as you can see, this white plastic thing comes off easily, and I thought, okay, let's replace it and build a 3D printable cap, and then put a Gameboy link cable port directly into the nose of this thing. So I started working, printed out the cap, the port, got a RP2040 and the level shifter that I needed. I did not use the board because it was too large, and the Raspberry Pi Pico is also too large, so I opted for these. So I removed the USB-C connector and soldered tiny wires here. And here is a quick side note. After watching ThinkMaker Q at Hardware.io crazy soldering skills, I decided, hey, I want to do that too. So I went to Amazon and ordered the tiniest wires I could find and started soldering them. I'm pretty proud of the result, and feel free to call me king of the solder. So moving on, we need to wire up the link cable port to the level shifter, and this is what I ended up looking like. And then all we need to do is put the link cable port inside the 3D printed plastic and hot glue everything in. Make sure that we connect one additional wire to the link cable port, because there's the 5V from the Game Boy directly, which we need to power the Pico. And then we connect the wire back from the Pico to have voltage reference for the 3.3V that we need for the GPIO pins. So far, so good. And then when I tried putting everything in, these tiny wires ripped. Well, I tried soldering them back on, but eventually I failed and decided to go for different wires. So instead I just went back to regular wires and soldered them on. So what you can see is that they're connected to the USB data lines on the printer board and to the where the USB-C connector has been on the RP2040. And we can test the connection by connecting the cable to the printer. And since we hooked up to the data lines, we should see the RP2040 show up as a USB device, because the printer itself does not actually talk to USB unless we power it on, and by default it's off. This is what it looked like. On this side there's nice-ish solder pads, and here, call me king of solder again, wiring up super tiny space wires, and it worked. So to make sure they don't rip, I put on a bunch of hot glue and then tried to fix also the other part. That worked pretty well actually, and this is how it looks like. And this is the mid result, I would say. And now the one thing left is to fit everything in the case. And that was when I realized I fucked up. Because as you can see, I hot glued the adapter into my pre-printed plastic. I wired up and connected everything, but the plastic goes into the printer cap from the other side. So I had to disconnect all the wires from the board again, and then I had to put them through the pink plastic cap from the other side and then solder them all back on. And while doing so, my USB data lines ripped. Damn it. So what I had to do is either grab a new RP2040, but that would pose equally as high as of a risk to rip the pads when removing the USB thing, or luckily the one pad that ripped had a trace under it. So what I could do is to scratch off the trace, and as you can see here in the picture, I put a little bit of solder on there and then soldered directly to the trace. So you can see that the pad to the left of the one that ripped is what we need, and then below it, the scratched away trace is where I soldered the other wire to. So, well, call me again king of solder. And that's what we got. I could finally fix it up, close it up, and this is what the final product looked like. Let's give it a test. Fuck! Alright, clearly that was not supposed to happen, so what the heck is going on? So I took out my voltmeter and started debugging and tracing through the lines and testing connectivity, and turns out I wired the one single most important wire I wired incorrectly, which is the red one. Because apparently on the link cable, the 5-volt rail does not go straight from Gameboy to Gameboy, but instead it is crossed to the other unused pin. So the 5-volt rail from one Gameboy goes to the unused pin on the other Gameboy and the other way around. I assumed with my setup that the 5-volt rail goes straight, which on the second thought doesn't make any sense. So since I covered everything in hot glue, there's no way I'm getting it off. So I had to disconnect all the wires, remove the cap with the hot glued adapter and the voltage shifter, and this thing I cannot get back. So I started printing another one, and then I started wiring up correctly this time. Trust me, I know what I'm doing. So the one on the edge is the red one, then goes the orange one. Actually, no, that's not supposed to be orange, but that's supposed to be brown. The orange goes on the other side. No, wait, on the second thought, this is in the back. This is not orange. I don't even have orange here. This is brown. So let's remove it and put in purple. And now add the missing 2 wires. Now, finally, I know what I'm doing, okay? So these I connect to the level shifter. Luckily, I ordered each of every piece I ordered 5 times before even starting this project, which came in handy after all, because this is the 3rd connector and the second logic level shifter. So after measuring everything before I put the hot glue on and make sure it's working, I started soldering stuff back on. However, first we wire the cables through the plastic thing to not have the same issue we had before again. So after we wired that and connected the one cable which goes directly to the connector, we can fill it up with hot glue again, and one last sanity check with the ground and the power rails, and then put everything back together and give it another test. And when connecting everything and trying to power on my Gameboy, as you can see, it just dies right away. Clearly, this is not supposed to happen. So what's going on here? I think we have a short somewhere. So I went and debugged the only reasonable way we can debug this. And that is by taking a pair of pliers and holding one end on the ground shielding outside of the cable while this is plugged into my Game Boy, and then using the other side to carefully tap those pins. So by testing all of them, I could figure out that there was one single pin which would cause the Game Boy to, let's say, crash in a way that we've seen it. And the only pin that this was applied to would be the 5-volt pin, because all the other pins, if it's a data or a signal pin, they are supposed to be grounded to transmit the signal, so they have a pull-up resistor. And then the ground pin, that doesn't do anything if we short it, and the unused pins doesn't do anything either. So by realizing the only pin which did cause the crash was actually the 5-volt pin, I thought, okay, so maybe it's wired up correctly after all, and the Game Boy's battery is just not powerful enough. But because up until this point I never actually tested whether all of this works with my Game Boy Advance SP. So far I only tested with the Analog Pocket, which has a sufficiently large battery. So before I did the debugging with the cable, I opened up the printer to check if maybe something broke. And by doing so, actually something did break. The USB connection broke. So I had to heat up the hot glue and try not to rip pads again. Luckily, when I started heating up the hot glue without air, one of the cables just jumped right in front of me. So all I had to do is somehow remove the hot glue without ripping up any more pads, then solder them back on in the king of solder style, obviously, and then put back on new glue. But before that, test it. So I did test and it worked, and then I put on more glue, and then I tested it again, and then I put back everything in the box, because I realized my Game Boy Advance is just not powerful enough. Did do a couple experiments, but eventually it did work just fine with the Analog Pocket. So yeah, success. We can finally print our Pokemon on our Game Boy printer. Yay. I eventually did manage to somewhat get it working on the Game Boy Advance SP, though it's not as nice as I hoped to, because this is the Game Boy from my childhood and the battery is really not in the best days. So after fully charging the Game Boy, well, as much as I could, and also charging the printer, because I've never really charged that since I got it, and additionally I also got the power bank, which is supposed to supply extra power to the Game Boy. I could get him working, although there are kind of some problems, because due to the way I wired up the power supply, because I expected the Pico to be powered from the Game Boy. When connecting the Game Boy to the printer to the power bank, actually power flows into the Game Boy, and the Game Boy does not like that at all. As you will see in a moment, the screen turns completely white as a result of power going from the power bank into the Game Boy, so I would not recommend anyone doing so. And here the first attempt didn't quite work, so there is sufficient power when both is charged to have the Game Boy run the Pico, and actually the printer also charges from the Game Boy while it is doing so. But as soon as it starts printing and the motor runs, the Game Boy can't supply sufficient power. So here you could see the first attempt didn't quite work, but disconnecting the power bank and reconnecting it actually did work. So here you can see it does transfer, and while it is printing, everything is fine, which we will see in just a moment. And then when it stops printing, you see the screen goes white because the power from the power bank flows into the Game Boy. But as soon as the printer continues printing and draws the power from the power bank, the Game Boy goes back to normal. So the Game Boy is still live, but I would not recommend doing so. And as soon as I unplug the power bank, the Game Boy is also back to normal. And it did work. It's not been part of my original design to not have the Game Boy have enough power. I don't know how the Game Boy Advance behaves with batteries, or the Game Boy Color, or the OG Game Boy, but I do realize that the Advance SP is the worst possible target because of the built-in dying battery. So I hope you enjoyed this project and watching me do it as much as I enjoyed doing it, with all the times I redone it. And if you want to try it out yourself, just grab a Raspberry Pi Pico, get a voltage level shifter, connect it to your Game Boy, and the source code is going to be public on GitHub. You can find the link in the video description. So yeah, I hope you enjoyed, and see you around.